G'day. A moment ago, I demonstrated the display of indexed PNG sprites on Frame. Now, how did that happen? I'm just running that now as well. So this is using the Frame message package, which has been released. This is the higher level package, and it allows you to create sprite messages and send them to Frame and then have some code on Frame that will display them. So how are we going to do that? I'm just going to talk through in a little bit more depth just to give you an idea. This time I'm going to jump into VS Code, and I'm using this Frame examples Python repository that I have a bunch of examples in. And if we just go in here, I'll look at this one that I ran was this sprite indexed PNG file. That's what this one was. So hopefully the text is big enough for you to read there. So what is inside this file? So you might remember the BLE file. We had to create a BLE object, a frame BLE object, connect, send some Lua and disconnect. This one, the main thrust of it, the part of it which is to do with the message passing, is after you start your Frame app on Frame, you then create a TX sprite object. So TX there standing for transmit, and there are some RX objects for receiving. But in this case, as a convenience method, I can create a TX sprite from a PNG file if it was prepared correctly. And then we just send a message. And then this send message does a bit of magic. It will split the message up into multiple packets and then reassemble it efficiently on the other side. And then it's going to pass this message to the Frame main loop along with this code so that the main loop can decide what to do with that message type. And so this program, as you might expect, that displayed 3 images, it will create 3 sprites, one after the other, and then just send them. And it doesn't delay in between them, although it does have a bit of a sleep at the end to show the last image for a little while. There's a bit more going on in this program though, and so I'll just quickly talk through it as well. So now we created a frame message object, which is similar to how we created a frame BLE object. We call connect on it in exactly the same way. This is inside an async function because we're going to be using a lot of awaited calls. So we await the call to connect, and when it returns, it will be connected. Otherwise, it will have thrown an exception out to our exception handler. This is for, I've marked it as debug only, but often when we connect a frame, we want to know what its battery level is. And if we're working with things like images, then we also probably want to keep an eye on memory because the memory is pretty limited. And so we can't just keep loading images on there. We've got to delete them and run garbage collection if we want to free up that memory. So it's generally good practice to check your battery and memory at the start. This, you may remember something similar from the BLE tutorial, which was that we wanted to do a frame.display.text and then do a show and so on. This is a convenience method for just showing a little bit of text during the stage of your program where you have not yet spun up the whole framework yet with message passing. So you can at this point send a piece of text and it will just display. But what we have to do with a frame message program is we have a bunch of helper libraries that come standard with the framework, which we choose to load onto Frame. This particular application we know will only use the data handler for assembling these messages from Bluetooth, and also the sprite helper, which is going to help us display the sprite. So I need those two, so I just say I want to upload the standard libraries for those. And then every one of these frame message applications will have a frame app, so a main loop that runs on Frame that dictates what this app does on Frame. There are sort of 2 parallel loops. On the host application, it doesn't need to be a loop, but there'll often be a loop that is doing a bunch of work, sending messages, receiving messages, and so on. And on the Frame side, there is this corresponding main loop, which we'll see in a minute is just another loop. It's in the Lua programming language, but it's quite familiar. And it will also just be waiting till it receives a message and then taking some action and then going back to waiting for more messages. So there's sort of this dual message processing loops. So we need to upload a loop like that, a program like that. Now the good news is there's quite a few example programs here that all have a program that runs on Frame that will do mostly what you want, and you might want to paste a few bits together, but they're a very good starting point for your own Frame app, particularly if you want to do something like display an image. There's already one here, you can just grab this one. Print response handler is a specific case that we want, particularly for debugging. It turns out that when you do a print statement on Frame in Lua, that print statement it gets pushed down the Bluetooth characteristic and can be read as a string of text by your program. And that's quite handy. So you can add print statements to your Frame code and then just see them show up in your console on the host, in this case on this desktop. There's one other thing that you do after you upload these 3 files, as it turns out, so the 2 small helper files and then your main program. Once you uploaded those, in Lua you do what's called require. You require the name of a module and then that will run it. So if it has, well, it will just simply run all the commands, and if it has a main function that you run, then it will run that too. And in this case, it will be running a main loop that won't terminate straight away. You'll need to send a break signal to break out of that main loop if it doesn't exit normally. So we actually have to do that. After we send our Frame code over, we just start the Frame app. But now all of this will be standard. All similar programs will use exactly the same few lines of code. So this can be pasted straight into your application when you get started. And as I mentioned before, we then create our 3 Sprite message objects and then pass them one at a time. And so every TX message, you can construct it using Python syntax, so you can pass in this rich number of objects into it. But every TX object that needs to be able to turn into a message needs to have a pack function, or it should have a pack function like this, which packs all of the contents of that message into a byte array. And that byte array is what gets sent across Bluetooth to Frame. And it gets matched with this code. So every type of message that you want to send to your Frame program that it needs to be able to distinguish between should have a unique code. And there's heaps of them. You can have 255 of them really. And so in this case, I've just picked 20. It's quite arbitrary, and you'll just see that number 20 on the other side. And as long as they line up, then if I send a message called 20 over here and I receive a message called 20 over there, then it's not too bad. If you had lots of these, then you could add things like constants to name them and enums to verify them and so on. But I was keeping this pretty simple, but that's maybe a matter of taste. And then there's a bit of symmetrical activity here. So we had a print response handler that we added, so we were starting to read the strings coming from Frame, and we had a start Frame app. Well, down here we're also going to detach the print response handler, so we no longer want to print out what comes from Frame on that characteristic to the console, and then we also want to stop the Frame app, and that's actually going to send a break signal to stop the running main loop, and it's also going to send a reset signal to Frame, so it's going to reboot again. If Frame has a file on it called main Lua, then that will be the program that automatically runs when Frame reboots. So Noah, for example, has a main.lua, and if your phone has loaded the Noah app onto your Frame, then it will run when this reset occurs, which is the same as when you put it in the charger and take it out again, it will get a reset signal as well. And then there's just a little bit of cleanup. So there's not a huge amount of code. In order to get images displayed, there's a fair bit of going on inside of this TX Sprite class to pack the appropriate message for Frame. And there's a fair bit going on in that data class to be able to split the messages and then reassemble them. But you don't have to worry about any of that when you're using this part of the library. So that is the host side of that application, but what's happening on the Frame side? We should spend a few moments looking at that. So each of these examples, some of them share a Lua file, but each of them have a corresponding Lua file, and this one is called Sprite Frame App. So what does a Lua program look like, perhaps for somebody who hasn't spent much time looking at them. Not unlike the Python program really. In this case, these helper libraries, the reason why I knew to include these two helper libraries, data and sprite, was because I'm going to need them in this code. So data, all of the programs will need if they're going to assemble messages from the host. And then sprite is, in this case, because this program is displaying sprites, I require that one here. Now this module, when I load it, it won't run a main loop or anything, so it's just going to load a bunch of load up this object and hand it back to me as this table called sprite. Here I do actually use a constant to refer to this number 20, and if I had a few different message types that I was trying to choose between on the frame side, I can easily add constants here as well, so that's totally fine. This is a little bit of boilerplate that you will see in all of these types of frame side apps, and that is to tell the program which parser do I need to use to understand this sprite. So this message number 20 here needs to have a parser associated with it. So this array of bytes that gets passed over to Lua needs to be unpacked into a rich object, in this case a sprite object that has attributes like width and height and number of colors and palette information. All of that got packed into the byte array that got sent over. And so there's a corresponding parser that will unpack that into a sprite object. So again, your code only needs to deal with a rich object like a sprite. But you do need to tell it, it doesn't know ahead of time that on number 20 there's going to be a sprite. It could be any object at this stage. So this is where we tell it which one it's called. And then happily, whenever a message with a message code of 20 comes in, it will automatically call the parse sprite on that full data array and then place the resultant object in a place where your main loop can grab it. So this is the app loop. This is just a function. It will get run right down the bottom. It will actually run it. But here we're just defining the function. Here I'm going to print some text to the display that says frame app started. So that's what that one is saying, and then it will do a show, because as you might have remembered from one of the other tutorials, you always do draw calls to the back buffer, and then you flip the buffers with a show call, and then what was in front becomes the back, and all your subsequent writes go to that one. But so there will always be a show call after something like a display.txt or after several. It's fine. But then I do one more print here, and this print here, if it was a normal Lua program, would print to the console. It would print some text to the console, and that has been rerouted on frame to print to a characteristic that pushes the data back to the host. So that's when we attach the print handler, the print response handler, on the Python side, then it will read this, it will receive this message on that data response channel. So that's why we print it. And the reason why we do that is we don't always know how long this part of the program setup will take. And what we want to do is we want to be able to make sure that the frame app has started before we start sending it messages. If we start sending it messages before startup has completed, then we don't know what we're going to get. So the convention that I've adopted is that once you start your frame app, it needs to send at least a tiny bit of text back just to say, I'm ready. And the first bit of text that gets sent back will tell it it's ready, so don't send any text until you are ready. But once we're in the main loop, we are ready. So right before this main loop starts, we send the text. So perfect. So the whole main loop of the program is just this really. So after we've done that setup, all we have to do, there's a bit of error handling. This is what error handling looks like in Lua, this protected call syntax. But inside of here, all we do is we process raw items, and we're doing this in a pretty tight loop. As you can see, I've just got a short sleep in between iterations of this loop. We do it in a tight loop, and we just check for any new messages, and this will process anything coming off the Bluetooth handler, but only when items are ready, which means that a complete message has been received, will it return a number that's greater than 0. And so we just want to keep processing the data as it comes in. But when we get a full message, such as a complete sprite, which might be, tens of kilobytes or something, then this item's ready will go 1. It'll go to 1. And so that way we can then jump into this part of the main loop where we say, look, if we've got an item, if the user sprite is not nil, that means we've got a user sprite, then copy the reference to that sprite into this local variable called SPR, and then we've got a handle on this object. Now this is a sprite object. All of the objects in Lua are just tables, so they have attributes and functions and things like that you can set on them. But this object, we're just going to call it SPR. Now Sprite here is our module that we've included here, which has got some helper functions. So one of the things it's going to do is it's going to set the palette of frame to whatever the palette of this sprite is. So frame can have 16 colors, but your image might have chosen a different set of 16 colors to draw itself best. So this particular version of the program will set frame's color palette to match the image that you want to display before it tries to display it. And then it uses the command, which is if you look at the docs pages on Brilliant Labs website, you'll see the whole Lua API, all of the Lua commands that you're allowed to issue that other than standard Lua, there's a bunch under this frame object. And so frame.display.bitmap is the way that we show a sprite on frame. And in this case, I'm just putting it up in the top left-hand corner, but you can pass messages that include coordinate information as well, things like that, or your app might always display them in a certain place, that's fine. And then it uses attributes that are in this sprite object called width, bits per pixel. So bits per pixel is 1 for a 2-color image, it's 2 for a 4-color image, and it's 4 for a 16-color image. That's how many bits per pixel. And then you can even offset to shift the colors up and down the palette if you want to use some tricks like in the old video games. And then there's this huge block of pixel data, which should be the width times the height, times by the number of bits per pixel in bits, rounded up to bytes. So, but the framework does all of that packing for you, so that should all be a consistent object. And then we do a show. So we show this image, and then straight away we nil out that image and we do a collect to free up that memory. And that is because we don't have a lot of spare memory on frame. So if we've just sent an image and we can spare to delete it, then we will delete it. You might have a couple of little icons that you want to use lots of times in your app. Absolutely keep them there. Don't delete them straight after they've arrived. You could put them with different message numbers. So 20, 21, and 22 and 23 could be your little icons or spaceships or whatever. And you send them all over and you don't ever delete them. They live for the lifetime of the program, and every time you want to display a bitmap, you display bitmap number 20 or bitmap 21 or 22 or 23. But in this case, because they're quite large images, I've just shown them and I know I'm not going to show them again. I'm just going to delete them and free up the memory straight away. That's just a pro tip. Otherwise you will run out of memory if you keep sending stuff over to frame. Like I said, then we just sleep for a tiny amount of time and then go all over again. So this is a reactive loop that's just waiting for events, and then when it gets a message, so I'll display this image. It could do something else, right? At that moment, when it received a certain kind of message, it could print some text and wait a few seconds and then display an image. It could do all sorts of things, because the message passing from the host is not, this part is not awaited. So it doesn't await until the image is displayed. It awaits until the message is fully received. But yeah, you can run custom code on frame at this point. It's its own program. And then this is just an error handler here. If there would be a problem, it's going to clear the display and then exit. So that way, that's all there is on the Lua side. So it is, like I say, there's a main loop that's reacting to messages being passed from the host. And if you compare that to what is on the host side, then you have, after the setup where you have to send a few files over to frame to get it set up, you just run the program on frame, and then you just, in this case, pass 3 messages over, wait, and then disconnect and exit that main loop on frame as well. Otherwise it would keep waiting for new images to come by. So there you have it. Two main loops spread across two programs, and that's really all there is to it. Let me know how you go.